Hi guys, welcome to my YouTube channel. So today we'll be doing revision mathematics grade 12. My name is Jabulile Ngobeni and I will take you through only 4 questions. So we'll be doing question 1 on the preparatory examination paper grade 12, question 2 and question 4, and the last one will be question 7. So let's start with our question 1. So on question 1, 1.1, we were given that f of x. I hope you guys have your question papers next to you. F of x is equal to x squared minus 3 brackets multiplied by 3x, and the last one adds x plus 2, Okay, the first thing that we are going to do, we are going to solve for f of x equal to 0. When they say f of x equal to 0, they mean that you equate all these equation with a 0. So we are going to have 0 is equal to x squared 3x minus 1 into x plus 2. Therefore, when we solve for this, we need to have x squared equal to plus or minus is equal to 3, x squared or 3, or x is equal to 1 over 3. We transpose this one, it becomes positive, and then we divide it by this 3 to be left with x, and then or x is equal to negative 2. So we are going to have, if you want to have here, so we should introduce square root sign, yeah? So we are going to have x is equal to positive root 3. So our first question on 1.1.1, we are asked to find x if it is an integer. So our answer here, we have x is equal to, we are going to have x is equal to 2, right? And then for 1.1, we are asked x is a rational number. So rational number, we are going to have 1 over 3. Okay, we say that x is equal to negative 2. So for 1.3, we ask if x is a number. So all these numbers are real numbers. I'm sure you guys can remember that from your classes, being taught that what numbers k or x is equal to 1 over 3 or to negative 2, right? So I'm going to divide this page so that we can tackle question number 1.2. So on 1.2.1, we are asked to x if you have negative 15 x squared minus equal to 0. And they are saying that you should correct it to 2 decimal places. When they say correct to 2 decimal places, 3 decimal places, or 1 decimal places, we all know that we have to use the quadratic formula. The quadratic formula is given by x equals to negative b plus or minus the square root of AC all over 2a, right? So we are going to add our values. So for b we have negative 9. You should avoid taking only because the sign matters, not unless it's positive, but when it's negative you should take negative 9, not 9. Okay, we are going to substitute b by negative 9 plus or minus the square root of negative 9 all squared. For our a gets negative 15, right? We have negative 15, and then our c is just 4. I'm sure you guys can see. And then all over 2 times what? Times 4. Okay, so my answer is that you can punch on your calculators. I got negative 0.90 x, or another x is equal to 0, okay guys, you can just pause the video so that you can copy if you want to. So I'll just erase this. So when I erase this, we are going to question number 1.2.2. So the question here from 1.2, we are asked to solve for x. So from 1.2.1 we're given that is negative 15x squared minus 9x plus 4, which is the one we just did. So we are going to do 1.2.2. okay, so let's just erase here so that you can go to 1.2.2. okay, for 1.2.2 our question is 3x minus 2 all squared greater or equal to 3x, right? So when we solve for x, in this case we have to solve for this whole thing, eh? So after solving this, we are going to have 9x to the power 3, which is 3x all squared, 9x to the power 3 minus 12x plus 4. Okay, let me write this correctly. Plus 4 is greater or equal to what? 3x, right? So we are going to take the 3x, this 3x, and put it on the other side. So we're going to have 9x cubed minus 12, no, it's not x cubed, it's x squared. Sorry guys, so these are some of the mistakes that you guys should do when writing. We're having 9x squared is 3x to the power 2 minus, we double the term, right, which is 6x plus 6x. We are going to have 12x and then plus what? Plus 4 is greater or equal to 3x, right? Then we take the 3x and put it on this side. Minus 12x minus x plus 4 is greater or equal to what? 0, because we have taken this 3 to the other side. So our factors are going to be 3x minus 4 in 3x minus 1, because this and this will give us 15. So the two factors that we'll multiply, when we add them, add or subtract them, they give us 15x, right? So it's greater or equal to 0. So x 1 over 4 is, so that's our answer. So we're going to 1.2.3. 1.2.3, our question is that to the power x, 5 to the power of x, let me check the question clearly. 5 to the power of x is equal to into 4 plus 5 to the power, close bracket, right? So after closing this bracket, then we are going to solve this question, right? So we have to the power of x, we have is equal to 5 to the power of, okay, so we are going to multiply this. All right, we have 5 to the power of x, this side is equal to 5 times 4 is 20, and then we have positive here, and then we have 5 times 5, 2. So we are going to have 5 to the power of x is equal to what? Is equal to 20 plus 5 to the power of 1, which is 1, times 5 to the power of 2. We are taking 5 to the power negative x to the denominator to make it positive, 5 to the power of x. And then to solve for x, we are going to then, okay, let me try here. We are going to let 5 to the power of x be any variable so that we can solve. Okay, let me say 5 to the power of x is k. So where there is 5 to the power of x, we substitute it back with k. So we are going to have k, this side is equal to 20 plus the power of 1 multiplied by 5 to the power of 2 all over k again. Then we multiply k with the k. We are going to have k squared is equal to is equal to 20 plus what? Plus 125, right? Plus 125. Then we are going to have k squared minus 125 is equal to 0. So we are going to solve for k. We have k this side, which will give us k squared, and then we have 5 times 25. This is 125, that when we subtract them we get 20. So 25 minus 5 is equal to 20, but 20 is negative, signs are not the same. The bigger number must be negative and the smaller one must be positive. So we are going to have k plus 5 into k minus 25 equal to what? Is equal to 0. So when we are solving k, we are going to have we substituted 5 to the power of x. So we're going to have 5 to the power of what? To the power of x is equals to negative 5, or 5 to the power of what? To the power of x is equal to 25. So where there is okay, then we are solving for what? For x. So x is not equal to what? To a negative number. So we're going to deal with 5 to the power of x. So 5 to the power of x, we have to change this 25 to be like 5, because when we multiply, or when we have powers of the same base, we can equate the exponents. Okay, then we are going to say 5 to the power of 2. There's nothing that I've changed here. It's 25 and it's 5 to the power of 2. If you can punch it on your calculator, 5 to the power of 2, it's equal to what? It's equal to 25. So we are going to have x is equal to 2, right? Okay, you can pause the video because I'm about to erase everything so that we can go to the next question. We'll go to the next question. So guys, I think that I'll only erase only one side so that we don't waste time. So we are going to be having what? 1.3, and 1.3 we have to solve for x, solve x and y, ne? So we have log 16 log x 16 log 16 base x is equal. For y, we have y is equal to y plus, no, here. So we have y plus the root of x plus 7, x plus 7 is equal to x plus 1, ne? Okay, sorry about that. Okay, we have x plus what? Plus 1. Alright, so when we solve this, we are going to have x to the power of 4. I believe that you have learned about logs is equal to 16. So x to the power of 4, 16 to the power of what? To the power of 4, so that you can equate the what? The bases. So it's 4, it's 2 to the power of 4. And then our x is equal to what? Is equal to 2, right? So we substitute x equals to 2 in this equation. So this is equation 1, and this is equation what? Is equation 2. So we substitute this x equal to 2 into this equation. So we are going to have y is equal to x plus 1, right? X plus 1. Then we can transpose this to that side, which is negative x plus 7. And then we substitute with the 2 is 2 plus 1 minus the root of 2 plus 7. Okay, this will give us what? A 0. You can check with your calculators. So we have x, we have already solved x and y. We have x as 0 and we have y, you have x as 2 and we have what? We have y as 0. Okay, so you can also pause the video even now so that you can later access it. So let's erase so that we can go to 1.4. Okay, I don't have a much faster way, guys, of erasing this, so I'm trying by all means to be fast. So we are going to be going to 1.4 now. We are going to be going to 1.4. We are still on question 1. So okay, it's still question 1, but we are going to 1.4. So the question in 1.4, it's saying that calculate the numerical values of p so that x squared plus p into 2x plus 7 plus 8 is a perfect square. Alright, so our answer will be, okay, we first say x squared plus p plus p into 2x plus 7 plus 8. We have x squared plus 2p plus so we are going to have 2p squared minus 4 into 1 plus 8, which will be, this is plus, guys, which will then be 0 to 4p squared minus 28p minus 32. So 0 is equal to, we have p to p 1, right? Therefore p or p is equal to negative 1. We are done with 1.4. Alright, so we are going to question 2. So the total marks for this question was 25, right, guys? I hope you guys wrote this question paper very well, or this preparatory exam very well. So question 2, we are going to be having a number pattern, ne? Okay, the question here is saying that the following sequence of numbers forms a quadratic what? Number pattern. I won't write that statement, but for question 2, okay, the number pattern is -3 is 2, -2 is 2, -3 is 2. Okay, this is -3, is to negative 6 is to negative 11, then and so forth. Okay, 2.1. Okay, let me write it this side. So we are required to find the first differences of the given sequence number and also form a sequence. Determine an expression for nth term of the first differences. Okay, for the first differences we have positive 1, negative 1, negative 3, and okay, our A is equal to 1 and our difference, our D, is equal to negative 2. Negative 2. So for us is equal to D. Okay, I hope for this we have Tn minus 1. Guys, this is into n minus 1d. There's no n here. Okay, 1 plus n minus 1 minus 2 is our difference. Okay, we are erasing it. It's a plus n minus 1d. Okay, times the negative 2 because our d is negative 2. So our Tn will then be equal to 1 minus 2n plus what? Plus 2. Therefore, Tn is equal to negative 2n plus 3 because we have these 2 and 1, 3. Yeah? Okay, let me write 2.2 here. 2.2 is saying that calculate the first difference between the 35th term and the 36th terms of the quadratic sequence. So we are going to take this Tn is equal to negative 3. So we are going to what? To substitute T 35 to negative 2 into 35 plus what? Plus 3. Therefore our T 35 is equal to what? Is equals to negative 67. Easy. So guys, I think this was very easy for you. If you have revised everything you've done in the class teacher, so I think this one was very easy. Okay, we are going to question 3. So question 3 is saying that I mean 2.3, not question 3, guys. 2.3 is determine an expression for the n term of the quadratic sequence. So I won't erase this first difference. Okay, I won't erase this difference, so I'll just say this is 2.3. This is our first difference from this equation. How do we obtain a first difference? We say negative 11, we minus this one, and then we got negative 5, and so forth, like this. Let me just do it so that those who have forgotten will get it. So here we are going to obtain a positive 1, and then here we are going to have 1, and then here we're going to have a negative 3. Here we're going to have what? A negative 5. This is what? Is the first difference. Different. It's the same as this one. So I was trying to what? Okay, for the second difference, we have negative 2 here, negative 2 here, and what? Negative. This is what? Our D. second difference. Okay, so we're going to have Tn is equals to an squared plus bn plus what? Plus c. But 2a is equal to what? Is equals to negative 2. 2a is equal to negative 2. So we are going to have Tn is equal to negative n squared plus bn plus c, which is then T1 is equals to 1 squared, which is negative, plus what? Plus, okay, plus b plus c. Okay, we're trying to have, okay, this is then equal to negative 2b plus c. This is equation y. Okay, T2 is equal to negative into negative 2 squared plus this will then be, for time we are going to say this is 2 equals to, they have solved it, plus c. We just want to maintain time, and then we are going to have equation 2 minus equation 1. Therefore b will be equal to 4, then c will be equal to negative 6. So negative 6. So our Tn is equal to negative n squared plus 4n plus, it's a minus here, minus what? Minus 6. Okay, so that's it for question 2.3. Therefore our question 2.4, let me just read the question while erasing here. The question is saying that explain why the sequence will never contain a positive what? A positive term. We should explain why this sequence will never contain a positive term. We should explain by means of what? Of, you can just use calculations, or you can just explain using words. So I'll just explain it, so you should write down. So my explanation is that the turning point of a maximum quadratic function is 2 is to negative 2. So no values above the x-axis, hence no what? No positive values. So let's go to the next question, which is question 4. I said that we are going to do question 1, question 2, question 4, and question 1 and question 7. So for question 4, the question, let me check the question. For question 4, we have a graph. So the graphs of the functions f of x, a equals, okay, a over x plus p plus q and h of x equals to mx plus c are sketched below. I hope you guys are looking at your question papers. So we have 4.1. For 4.1, we are going to write down the values of p and q. So the value of p is equal to what? Is equal to 2. As you can see from the graph that the value of P is equal to 2. Let me write the 2 nicely. So is equals to 2, and for Q is equal to what? Is equal to 4.2. I hope you guys can see that the value of P is equals to 2 and then of Q is equals to -1. So we are required to calculate the value of A. Okay, to calculate the value of A, we have this formula of A over X. It's not a formula, it's an equation over X plus P plus what? Plus Q, and Q. We just substitute the values of A. Okay, we have A all over X. We have negative P, it's 2, and then we add what? -1. Okay, on this other side we have negative what? Negative 5 over 2. So our A, when you check on our calculators, will be equal to 3. So okay, for 4.3 we are going to 4.3. We have write down the range of F. So the range is equal to is the real of real numbers where y is not equal to what? It's not equal to -1. So for 4.4 we are going to move fast, guys, because of time. Our 4.4, we have to determine the equation of the line of symmetry of F for M is less than 0 in the form y is equal to. When they say in the form y is equal to, your answer will start by y is equal to. So our M is equal to negative, and then y will then be equal to x, in that to say y minus into -1 equal to 1 into x minus into -2. Okay, then y plus 1 is equal to x minus 2. And then when you take this one and transpose this to the other side, we're going to have x minus what? -3. When it goes that side, it becomes what? It becomes negative. So our 4.5, which is the last question for our 4.5, we have write down the equations of asymptote of f into plus 4. Okay, f. Okay, let me write it correctly. The equation is f into x 1 over 2. Okay, so this will then, we find that it moves 4 comma this 4 comma 1 2, it moves 4 comma 1 4 multiplied by 1 over 2, it moves 4 comma 1, I mean 4 1 over 2 units to the left. So we are going to have x equal to -6 1 over 2, right? Then y will be equal to -1. Okay, I hope that you all understand this one. So we are going to tackle Question 7. So question 7, it's a financial mathematics where we deal with money. So let's check the question while we erase. Question 7.1. Okay, let's continue erasing here. Okay, question 7.1. I won't write the questions, guys, so you should check them from the question papers. Okay, it's questions 4.1. I'll just read the question. A business buys a machine that costs 7.1. A business buys a machine that costs 120,000. The value of the machine depreciates as for per annum. Per annum is yearly, according to the diminishing balance method. Okay, that's the question, that's the statement. Okay, 7.1, we are required 7.1.1, determine the scrap value for the machine at the end of what years. So we have this formula: A P into 1 plus, no, it's not plus, 1 minus I to the power of what? To the power of n. So we are going to substitute into 1 minus, our I is 0.09, which is 9% divided by 100, right? And then to the power of 5 years. So our answer will then be 74,883.86 cents, right? Okay, and then we go to 7.1.2. Let's read the question. The question says that after 5 years, the machine needs to be replaced. During this time, inflation remained constant at 7% per annum. So now we have per annum. So determine the cost of a new machine at the end of 5 years. We still have got 5 years here. So for 7.1.2, we have A is equal to P into what? Into 1 plus I to the power of what? Power of n. Our P is still what? Is still 120,000 into 1 plus what? 0, to the power of the answer. So our answer is 168,306, what? 21. So that's it. So then we are going to 7.1.3. So 7.1.3, the business estimates that it will need approximately 90,000 by the end of 5 years. A sinking fund for approximately 90,000 into which equal monthly installments must be paid is set up. Interest on this fund is 8.5% per annum, compounded monthly. And then, so the first payment will be made immediately, and the last payment will be made at the end of the what? Of the 5-year period. Calculate the value of the monthly payments into the sinking fund. Okay, so for the sinking fund, we are going to say that 7.1.3. From question 7.1.1 and 7.1.2, the estimated value of the second fund. That's where we are going to find it by saying that the value of 168, what 306, it's 168, not comma, we have 168 306, comma 21 minus the 74,000 that we got. It's so comma, not, I don't know where I get these commas, guys, which are mistakes that you shouldn't do. Avoid doing them. 883, comma 86. The value of 93,000 rands. 93. Okay, let me write this correctly. We have 93,000 rands, 422.35 cents. Ne? So for the second fund, we are going to say that this will be F. Our formula is F is equal to X into 1 plus I. Okay, let's put this in our brackets. Power n plus 1 minus 1. This is all over. Let's close this bracket, which will be equal to what? 1000. So this will be X into 1 plus 0, 0, 0,085 all over 12 because it's compounded monthly, and then of 61 minus 1, which is equal to 90,000. 90,000. This is all over 0,085. X is then, our X is equal to 1184, 6 rands, right? Okay, then our last question for 7.7, for question 7, I mean, it's 7.2, which says that Kasala receives an amount of 900,000 upon her retirement. So Kasala retired, right? So she invests this amount immediately at an interest rate of 10.5%. Okay, let me write 7.2. Okay, she immediately at an interest rate of 10.5% per annum compounded monthly. She needs an amount of 18,000 per month to maintain her current lifestyle and plans to withdraw the first amount at the end of the month. How many months will she be able to live off of her investment? Okay, we are going to have P is equal to X into 1 minus into 1 plus n all over I. We're going to wants to invest, then our X is the 18,000 into 1 plus our interest rate is 0.1 all over what? All over 12 to the power of negative n, the number of months. So this is all equal to 900,000. Okay, ignore this, and then it is all divided by what? By 0.105 all over what? All over 12. Okay, when we calculate all this, because of time, with 1 minus 7 over 16 is equal to 1 plus 0.105 over 12 to the power of negative n. So to solve for n, okay, let's just first write this nicely. We're transposing this one to the positive. We're going to have 1 0.105 over 12 to the power of n, 16 over 9. 16 over 9. Then we introduce the logs. Therefore, we're going to have n log of 1 plus, okay, this plus sign must 1 plus 0.05 105 over 12. Then the log of what is equal to the log of 16 to 66,043, but we don't have 16,043 months, so we are going to have n is equal to 66, right?